Hello and welcome to section 2 of this Unreal Blueprint course. I hope you had fun learning and building the game Marble Run in section 1. In this section, we're going to be kicking it up a gear by building a new game that I have titled Crystal Cavern. We're really going to start getting to the meat of Blueprint by working with Blueprint classes, variables and functions, Unreal motion graphics and more. In this lesson, we're going to create a Blueprint project for our game Crystal Cavern. We're going to create an empty level, and then we're going to set the default level to open for the editor and also for when we package our game. So to get started with creating our blueprint project for the game Crystal Cavern, we first need to come to the Epic Games launcher. We want to make sure we're inside the Unreal Engine section of the launcher. In the first section of this course, we downloaded and installed Unreal Engine 4.20, and we're going to continue using this version of the engine. So to launch this, we can see when we're on the Unreal Engine section of the Epic Games launcher, we can see in the top right we have the big launch button, so we can just launch the engine here. Now if it's showing a different engine version, you can drop down this arrow next to this and you can select your 4.20 installation that you downloaded in the first section. So when you're ready, go ahead and click the launch. I'm going to minimize this and we're going to see a splash screen pop up in a second, and it's going to boot us into the Unreal Project browser. Now we want to go ahead and switch over to the new project tab. We're going to create a blueprint project, so we're going to leave it on this blueprint template tab here, and we want to start with a blank template. We're going to leave it on desktop or console for the target hardware, maximum quality, and we want to make sure that we do include the starter content because we're going to be using this to build our game. We can find a directory on our machine where we want to create the project to. I'm happy with mine under D/Unreal Projects. I'm just going to name my project here. Using the camel case naming convention, we can name this Crystal Cavern. And when you're ready, you can just hit Create Project. It will close down and it will start launching the editor with our project. So the editor's launched and we can now see that it's booted us into the minimal default level. So this is set up by default to launch when we either launch a packaged game or launch the editor. So we want to take a look at fixing this with our own level. First, we need to create the level. So we're going to come up to File and then New Level. And here we can choose a template for the level. We used default in section 1, but we're going to use empty level for this section of the course. So the empty level has no actors in it at all, and we can see this in the world outliner that the level is built up out of completely nothing. So right now I have a challenge for you. I want you to save your level. Using what you've remembered from section 1, I want you to save your level, and then I also want you to set the editor and game default level to your own level. And a hint here, you want to be looking in the project settings to do this. So pause the video here and give it a go, and when you're ready, come back to the lesson. So to achieve this, we first want to save the level. We can do this by coming up to File and then Save Current or Save Current As. So we can click one of these, and now it's going to bring up this Save Level As window where we have the content folder here. We can right click on this and we can come to New Folder. We can just name this something like Levels, and then we can name the level that we want to go inside of this folder here. I'm just going to name mine Level 1, and we can hit Save. Okay, so we can see in the content browser, it's now added this new folder, and here is our Level 1 that we are currently in here. So how do we set this as the default level? Well, we can come up to Edit, and then Project Settings, and then we can come to the Maps and Mode section here, and we can just drop down the Editor Startup Map and the game defaults map here, and we can choose our level 1 that we've created. Okay, so this is a good endpoint for this lesson. We now have a new blueprint project with a blank empty level ready for us to start developing our game Crystal Cavern in. So in the next lesson, we're going to start blocking out our level and also taking a look at lighting. So when you're ready, I'll see you in the next lesson. Hey, welcome back to lesson 2 of section 2, which is level blockout and lighting. In this lesson, we're going to take a look at different viewport view modes. We're going to start blocking out a level We're also going to take a look at how we can add lights to our level. And regarding lighting, we're going to take a look at the difference between pre-computed or dynamic lighting. And we also want to disable a default post-process effect known as auto exposure or eye adaptation. So let's get started with our level blockout. We're going to make use of the BSP geometry tools that we used in section 1. And we can find these on the modes panel underneath the geometry section. So we have all these different shapes, and we can choose if we're working with additive or subtractive brush shapes. We're going to leave it on additive, and we're going to just go ahead and drag out a box. Now let's take a look at what happens here. So I've dragged out a box, but we can't really see it. We see its outline, but we don't see the box. You might see it like this, or you might just have it blacked out like this. Okay, so the reason for this is because we don't have any other actors in our level. The default level has a skybox and a directional light that casts the light for us, the sunlight basically. But we don't have any lights in our level, so we need another way of working without having to rely on lights. Well, we can do this easily by changing the view mode of the viewport. We can see we are in the lit view mode on the viewport. We can click this and we can change this between different view modes. For example, we have this unlit mode and it says renders the scene with no lights. Okay, so now we can see our scene without any lights here. So this is a good place to start working. So in Crystal Cavern, the player controls a sphere that has physics simulated on it, and we're going to navigate around the level and collect these little pickups. Now we're going to design the level with these kind of pitfall gaps between the floors as we move along. So our level blockout is going to contain some floors, and we want to make sure that we have some gaps between them. And then we can just add some simple walls around them. Okay, so we have walls, we have the floors, and we have the gaps between the floors. So your challenge right now is to try and design a simple level blockout such as this. So using the BSP tools and what you've learned from section 1, just pause the video here and try block out a simple design such as this. But don't worry if you can't remember, because in just a second I'm going to walk you through the process. So to block out this little design, I first want to make sure that I'm in the unlit view mode. I'm going to change the location of my box brush to 0, 0, 0. I can focus the box brush in the viewport by pressing F. And I want to take a look at adjusting the height of this box brush. This is going to be the floor. So I'm going to change this Z height here, or the Z brush shape, to 20. This is 20 units or 20 centimeters. And we can adjust the width of this. This is going to be the Y direction. We can adjust this to 1000. And now I want to change the length of this floor piece. To do this, I'm going to use the geometry editing mode, and we can find this on the modes panel. With this selected, I can select this face here, and with the snapping turned up, I'm just going to drag it out to give me more of a longer floor piece here. Now I want to create that little gap here. So there's two ways we could do this. We could use additive and subtractive brushes, or we can just take the floor and just hold left alt and duplicate it over. So I've got a simple little gap here. I might just give it more of a gap by dropping the snapping size and just moving it over there. Okay, I'm going to use left alt again and drag to duplicate and get an even larger gap here. Okay, so now all that's left is to get the walls in here. So to do the walls, I'm going to drag out another BSP box brush. I'm going to change its location to 0, 0, and I'm just going to leave it at 100 because now this sits perfectly on top of the grid. Now I just need to move this to the side to make it a wall, and I want to adjust its height. So I'm going to use the geometry editing mode and select the top face and just move this up, say to about this kind of height here. Yeah, that's good. And then we can find the face that's pointing in the same direction as this red arrow. I'm going to select it, and I'm just going to drag it so I can change the length of this wall. Okay, we can hit escape to deselect it, and escape again to completely deselect that. We can come back to the place mode, select the wall, and hold down left alt and drag to duplicate it to the opposite side. So now that we have our level blocked out, let's take a look at adding some lights into our level. So to do this, we can find lights on the modes panel. We have the light section, and we have some different light types here. Let's just work with the directional light. Before we drag it out, let's change the view mode from unlit back to lit. So everything's really dark, but if we drag out the directional light now, we can see that it's a lot brighter. Okay. When we have the light selected, we can change its intensity on the details panel. So we have the intensity here. We can click and drag this slider to adjust that. But notice what happens if we bring the intensity down quite low. I'm going to set mine to 1.5. Okay, so it's made it darker, but look, it's ever so slightly kind of getting brighter and glowing. So this is a default post-process effect that's active in Unreal. It's called auto exposure, but it's also known as eye adaptation. And we can disable this by coming up to edit and then project settings. And then under rendering, if we were to scroll down, we can find the default settings here. Okay, we can uncheck auto exposure. And now when we close this and return to the level, we can see that it's no longer glowing and changing the lighting here. So I'm going to keep mine quite low to around 1.5. Now we have this mobility section just above the intensity. The light is a stationary light. We have static. If we were to click this, we can change it to a static light. Look, it says lighting needs to be rebuilt, 16 objects. Okay, we have movable as well, and that message now goes away, and it also goes away when it's stationary. So what's the difference between all of these lighting modes? So if our directional light was set as a static light, this means that all lighting calculations are pre-built. This is also known as pre-computed lighting. Well, what does this really mean? Well, this means that there's no real-time lighting calculations being done. There's no real-time shadows. Because of this, we cannot move or change the color of the light during runtime. So if we wanted to set up a scenario where we move through a trigger box and the light color changes, we can't actually do that with static light. So there's some limitations here with them with regards to real-time gameplay. So this is why we see the message lighting needs to be rebuilt, because the lighting needs to be recalculated in the editor. It can't be figured out at runtime. So because of this, it's actually really cheap to render these lights. It's actually really good for the performance of your game to use static lights. Stationary lights are used as a trade-off between pre-computed and real-time lighting. So what does this mean? Well, stationary lights can cast real-time shadows. For example, if we had a character running around underneath a light, we would naturally want to see their shadow moving with them, and stationary lights allow this. But at the same time, if we had a static piece of the environment that would never move, such as a wall, then a stationary light would allow us to pre-compute the lighting for the actor. So we have the best of both worlds with stationary lights. If we had movable lights in our level, we would notice these little arrows around the lights showing us that they are movable. This is just a little editor icon letting us know that. Movable lights use fully dynamic lighting. There's no need to rebuild lighting at all for these. They cast dynamic real-time shadows for every single object, in turn making them a bit more expensive to render, but they are still totally usable to use in-game. Anytime you want to look at this information, all you have to do is just hover over static, stationary, or movable, and it will give you this information. Okay, but I'm going to leave my light on stationary, and I'm going to build the lighting. To do this, we can drop down this little arrow next to build on this top bar, and we can just use build lighting only. We have different lighting qualities. I'm just going to leave mine on preview, and we're just going to hit build lighting only. So the engine is now pre-computing the lighting for our level. This won't take too long for a level of this size, but the more static actors in a level, the longer it will take to build. So it's now complete for me. I want to save all my changes by coming up to File and then Save All. Okay, great. So that's the end of this lesson. You now know how to add lights to your level and also how to use pre-computed or dynamic lighting.